welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is, how can new material handling technologies support adaptive manufacturing concepts? Now, to help explain this, I'm joined today by Jeff Johnson, U.S. Mechatronics Product Manager at Beckhoff. And Jeff is very well positioned to answer this question, considering that Beckhoff is known for its release of two of these new material handling technologies, one of which is XPlanar, which uses levitating tiles to move products or components in any number of directions for processing, assembly, or packaging, and the extended transport system, which provides for independent control of magnetically driven movers along a customizable guided path. So, Jeff, thanks for joining me today. And let's start with the term adaptive manufacturing that's in this question we're answering. Because this term has been used a lot over the past 5 years. And though all the explanations I've heard about it are pretty similar, there have been some differences. So, explain first how Beckhoff defines adaptive manufacturing.
Hey, David, thanks for letting me join you for this podcast. I'm excited to talk to you and your listeners about our XPlanar technology. So, what does adaptive manufacturing mean? Well, to me, it means being flexible to rapidly changing production. How do we change production on the fly to meet, demand-driven products? I think a lot size one is our ultimate goal, to be able to every other product be a different product. XPlanar allows you to quickly change your product flow to changing demands. There's no mechanical track to follow, so you have that free movement of motion, so you can quickly change your processes. You can add processes, you can skip processes simply by changing the path that the movers follow. So it's an ideal product for what I consider adaptive manufacturing means, where we have to be quick on our feet to any change that comes along.
Okay, thanks for explaining that, Jeff. So, with that in mind, let's go ahead and move on to a more detailed look at Beckhoff's XPlanar flying motion system. But before we get into the applications for which this kind of materials handling technology was developed, let's start by, you did it a little bit there in your answer about adaptive manufacturing, but let's get into a little more detailed explanation of what XPlanar is for those who may not be aware of it yet. So can you explain how XPlanar was designed so that its floating tiles hover above the surface while also being able to rotate and or tilt to deliver materials as needed?
So XPlanar is based upon magnetic levitation principles, which have been around for a long time, because, you think of mag levitation trains, those have been around for a long time, but they simply have like a 1D path. The principles based upon, think about back to our first physics labs where we played with magnets. We had red and green ends, and when you put the red and green ends together, they attract, and light color ends, they repel each other. So with the XPlanar, the mover is passive. It has permanent magnets and a Halbach array. And a Halbach array means you've got really strong magnetic field on one side, in our case, the bottom, and very weak magnetic fields on the top. The coil or the tile then contains all of, like, the base of the machine. It contains all the electronics for powering the coils, for powering, the electromagnetic fields, and then also all the feedback and diagnostics with it. So on the surface of it, there's a lot of very flat coils, and that's where the name XPlanar comes from these very thin planar coils that are on the surface. So by generating an electromagnetic field with the coils, we're able to lift or float the mover. And then by varying these electromagnetic fields, we create that free 2D motion, which actually has 6 degrees of freedom. So by varying those fields, we can move in any direction that we want.
So how fast can these tiles move effectively without impacting, what they're carrying, and how do they avoid collision since they're not moving along a physically defined path?
Okay, so with XPlanar, we can levitate the mover 0 to 5 millimeters. So the higher up you go, the more force or current's required to float it. We look at like 2 millimeters being the sweet spot. So at about a 2 millimeter flying height is where we do, we create all of our specifications. So at 2 millimeters, we can move up to 2 meters per second with a 1G acceleration. We have different mover sizes. Payloads range from 0.4 to 4.2 kilograms, but then you can also mechanically link or and software link movers together to carry even heavier loads. From a collision avoidance standpoint, we take care of that all inside our TwinCat software. So XPlanar programmed and controlled by our TwinCat automation software, and we have built-in collision avoidance to make sure that movers don't hit. And you program that gap, so if your tooling extends beyond the mover, then you can take that into account for your gap to create the gaps between movers.
Okay, thanks for explaining that, Jeff. So, XPlanar is clearly a very innovative technology, especially for the automation industry that isn't particularly well known for the most cutting edge of technologies. But flying motion technologies like XPlanar are clearly something different. So, what drove Beckhoff to develop a new technology like XPlanar?
So XTS we released that low over 8 years ago, and we have over 1,800 applications running worldwide. 6 years ago, we started developing XPlanar as we were seeing lots of applications that would benefit from the free 2D motion. Well, you know, XTS has, obviously we've done lots of applications with it. You're still in that 1D motion. We can do very fast, high speed applications with it, carry heavier loads, but we saw that need for this free movement. So with XPlanar, it allows you 6 degrees of freedom. We can move in the XY plane over the entire surface, the tile area, how you lay your tiles down. We can raise and lower the mover 0 to 5 millimeters. We can tilt the mover plus and minus 15 degrees in X and Y. And then we can also rotate plus and minus 5 degrees while in motion and up to 600 RPMs while stationary in the X and Y. So this 6 degrees of freedom opens up the door for many different applications. Beckhoff has always been and will continue to be, a leader in new innovation. So we're always looking for the, the next step. Where's going to be the next new innovation in industrial automation?
Yeah, I like that you mentioned XTS, Beckhoff's extended transport system, in your response there, Jeff. Because I was wondering, by now every devil's advocate out there has probably asked you this kind of question already, but why would someone want to use this new kind of flying motion technology that XPlanar is versus other more well known material handling systems like conveyors or even other advanced material handling technologies like the extended transport system?
So it really depends on your application. If you're just trying to move product from A to B, standard conveyors are probably the right solution. For high-speed packaging applications and assembly applications, XTS has been a great solution for it because it allows for that synchronous incoming and outgoing products, but you can have all this asynchronous motion in between to create your product. We found that when you design your process around the XTS or the XPlanar, you can reduce your footprint by 30 to 60%. So that's really big from an end user standpoint. XPlanar with the free 2D motion opens up the doors for new and innovative designs. Your tooling becomes simpler. So we have the XY motion on the mover. So now say we're bringing in a carton that we want to lay a glue pattern down. Typically, you'd have a 3-axis glue head would come over and lay your glue pattern down. That tool now simply becomes a 1-axis tool because we can bring that out, drop the Z down to dispense the glue, and then do the XY motion on using the mover. So now your tooling becomes simpler. So again, as you look at designing, you're taking the benefits of this 6 degrees of freedom, where even like leveling or as you're bringing a product in, if say your tooling's off a little bit, it doesn't have to be perfectly level to the mover. We can tilt the mover so that we're level to in relationship to the tooling. So again, it helps you with that tooling design. Every mover can follow a different path or go to different stations. So again, lot size 1. Not everybody has to index and follow everybody in line. We can, jump out a line and do whatever we want. Different products can even be run at the same time and on the same machine. You've got the freedom to lay out your machine in any XY format. So with the tiles, they're 240 millimeter square, about 9.5 inches square, and you can just sort of stitch those together in any grid pattern that you want. You could do rectangles, you can do lanes, you can do squares, U shapes, you can have offshoots. So again, it gives you this flexibility to mold your transport around your machine and around your factory. The big benefit is you really need to design your process around the XPlanar to really get the benefits of it. We started shipping starter kits to customers about 2.5 years ago. And later this year, you're going to see some really innovative machine designs on the market that are, were some of the first adopters of the XPlanar technology. So as we get farther into the year, we're going to see some really neat things out there.
Okay, thanks, Jeff. So, since explainer is so different from most material handling technologies that manufacturers and packagers are more familiar with, does explainer have any unique motion control or special programming requirements that end users should be aware of?
So XPlanar is configured and programmed using our TwinCAD 3 automation software. So we have a configuration wizard. So when you think about it, when you lay out the tiles and we connect them up to our controllers over EtherCAT G, we know electrically where those tiles are, but we don't know how you physically connected them together. So we have a wizard where you can go in and basically you just click on a grid pattern to show us what the physical layout of the tiles look like. Then from there you can add your movers, and then the user can configure tracks that the movers follow between stations. This allows you to have predefined paths. So we look at it as there's really three types of motion. The first one would be free movement, where you simply command movers to go to a specific location. So I could command a mover to go from one corner of the rectangle to the other corner. And if I also commanded another mover to go from the opposite corners where they would cross paths, if that first mover is in motion, we're going to, when you go to command the second mover, we're going to say, wait, we can't go yet because we'll collide. So then once that mover clears, then the second mover can go. So that's a free format where you just are giving it, the XY positions. And also, the user can configure tracks. Typically, when you're looking at system, you're going to have a bunch of processes that you want the movers to go. So you can create tracks and then tell a mover to join that track. And then simply, instead of having to worry about all these little XY positions on that track, you just tell the mover to join a track and go to the linear position on that track. So again, now we make it easier from a software standpoint. As you create these tracks that you want the movers to follow, you just tell them where to go on that track. And again, we have the built-in collision avoidance. So we could have, say, a buffer or a load position, and at the start of production, we could tell all the movers to go to that position on the track. The first one will stop at that position, and the rest of them will just simply line up behind it at whatever your program gap is. When the first one's loaded and moves out of the way, everybody moves up one. So again, we're trying to make this easy from a user standpoint. You can create stations that have switches and merges. So as you're switching between the predefined tracks, we allow you to, create these merge stations or switch stations, and you can give priority over, your product flow. So again, managing it is really simple. The third type of motion is what we refer to as a set point generation. In this mode, we can command the 6-axis to follow NCI or CNC coordinated paths. So again, as we go back to, say, the glue lane application, your X and Y can be the X and Y in a 3-axis coordinated path for laying down a glue or some sealant or whatever else you need to do. We can also follow custom cam profiles. So now with that 6 degrees of motion, we can create cams for all those 6-axis to follow and create what I call a wobbling motion. So we can wobble the mover to create the right mixing motion for the product.
So, as a materials handling technology, of course, explainer needs to be able to integrate with other material handling systems. In the case of explainer for loading and unloading of the tiles. So, how does that work, and how difficult is it to coordinate other systems with the floating tiles?
So it's not difficult at all, really. So, TwinCAN handles all the functions necessary to do this. We can synchronize the movers to robots or to an XTS or any other external device for loading and unloading on the fly. And in some cases, we load products on the fly. Other cases, we simply index a mover to a load station, and maybe you've got a Scara or a Delta robot that picks up the product and drops it on. We've got other applications where maybe they're coming in on a conveyor, and we simply move the mover in, and the tooling allows for the product to just sort of drop into the pocket on the mover. So again, same traditional ways that you load conveyors follow over with XPlanar. We can also send the position and speed of the movers to external devices. So we could either follow a robot, or we could have the robot follow us. We could also send that speed and position for cameras for doing, capturing images for inspection. If we want to do printing on the fly, again, we can feed the position and speed of the mover so that we can either print stationary or we can print on the fly.
Okay, thanks, Jeff. Can you give us a little more detail about some of those primary applications of explainer so far? And by that, I mean like what kind of industries has it been installed in, and for what types of material handling?
So we've been seeing interest from just about every industry, from food and beverage, pharma, assembly, lab automation, interlogistics. So, across the spectrum, people are seeing the benefits of it. The ability to handle, random product flow, coming in and have asynchronous motion between stations and then have that synchronous product flow out is a huge benefit. So being able to customize the path for each mover, it allows you to do small batches, different batches, so again, that flexibility of the changeover from product to product is very quick as more software than doing mechanical. The ability to buffer up random products. When you think of like say micro fulfillment, I've got random products coming in and I have an order to fill. So now I can have these random products come in and I can buffer the products in a staging area and then say, okay, I've got the 3 products to fill this order. Now I bring those 3 products over and maybe a robot picks those up, puts them in a box, and that box gets sent out. So again, this ability to take random stuff, sort it, and then when we have what we need, send it out is a big benefit. That feature is also being looked at for creating multi-packs. So as you go to the store, I've got the school starting back up. You've got the multi-packs of the chips or the crackers that the kids have. So again, now we could have that random product coming in. We can sort that and then present it to the robot that's doing the final pack out. So again, being able to bring in multiple things, sort, and send them on is a good benefit. The buffering also allows us to create, buffers of parts that can be used to fill gaps incoming. So think about we're filling maybe like a downstream flow wrapper or something, and our upstream production, maybe we're changing. It's being changed over. They're swapping something out, so the product flow is going to stop for a short period of time. Well, we can create a buffer of parts, so now we can keep feeding product out at a consistent gap for a small disruption upstream. And then once the product comes up, then we can just start, gradually refilling the buffer. So again, a lot of these benefits it just goes on and on. I've been asked, what are the limitations with it? And to me, it's really our imaginations. How can we, rethink what we're doing around the benefits of this technology?
So, since it's so different from most other material handling technologies on the market, how does Explainer compare cost wise with other material handling systems that are designed to handle similar capacities and speeds?
So it's difficult to compare the cost of it with traditional systems, as they transport in one dimension. So with Explainer now we have this 2D transport with the 6 degrees of freedom. If you need to rotate a part, you simply rotate it. So now we don't need a robot or someone to come over, pick up a box and rotate it so it's in the right orientation for downstream. So as you're comparing the two, there's a lot of these little things that you get with Explainer that it's hard to put a cost on. Another big one is there's no mechanical wear, so that there's no friction. So we have no belts to wear. Um, there's really no maintenance costs with the system. Explainer lets you rethink how you design your machines, making them smaller, more agile. You can do things you never could do before. So how do we put a cost on that? If you're just moving products again, like from A to B, Explainer is going to be more expensive and probably not the right solution. But the cost benefits really come in from being able to change product flow on the fly versus mechanical changeovers, handling multiple products on the same line at the same time, being able to vary the products and do more products without having to increase the footprint is a huge for the end users. Think about being able to use the most efficient, the highest throughput paths and processes that you can imagine for your production. Explainer can accommodate these. So it allows you to eliminate or combine machines or avoid having to do a costly plant expansion. So I could say the technology pays for itself, but there still is a cost associated with it. But as with any new technology like this, there's a lot of these additional benefits, and for me, it's hard to put an exact cost on that.
So I guess it really kind of comes down to the amount of flexibility that's needed in your production or packaging operations to determine, to justify the additional cost in that. Is that a fair assessment?
Yes. Yep. So,
Okay.
in a lot of the applications that we're doing, it's joint between, custom machine builders and their end users. And as they start looking at it and they start looking at the benefits, it just opens up this door where, the eyes get wide and it's like, oh, wait, well, we could do this, and and then, well, we could eliminate this downstream. We could combine this here. So it's that whole thought process of, we're not just transporting a product, we're designing a process around these benefits. The meetings are really fun because you start with, they're thinking it's another transport system, and by the end of the meeting, it's went off in all these different directions. It's really exciting these days.
Yeah, I imagine it opens up a lot of possibilities and potentials that people may not have thought about before. Yeah, absolutely. So, got time for one last question here, Jeff. And this one is, just a few months ago, Beckhoff announced an update to XPlanar that allows the tiles on the system to rotate a full 360 degrees. What benefit does this extra rotational ability provide? And are there any other such capability updates in the works?
So being able to rotate a mover 360 degrees and continuously up to 600 RPMs has lots of benefits. Now it allows us, we could apply labels. We can do 360-degree inspection of a part, so your cameras become simpler. We can orient parts as parts are being loaded downstream. We can look at them, and we can reorient the movers to make sure that they're in the right direction for downstream processes. The rotating along with the tilting of motion, like we talked about, the wobbling motion for mixing applications is really important. We're close to doing our next software update. We're fully released the 360-degree feature. We're also going to release a new mover bumper that's going to have unique ID. So now each mover on Power Up will be able to uniquely identify them worldwide. So this, it's a unique ID. So this is going to allow you to track your products even through a power cycle. So again, one big benefit of both XTS and XPlanar is the traceability of your products, because we have the product, we carry it all the way through the production, and so having this ID now, even through a power cycle, we can recover from a power cycle. We know where the movers are. We can look and see where everyone is and make the intelligent decision: can we continue production, or do we need to prompt an operators to can we continue with this part or not? We've got lots of new features, in the works, but for those, I think we'll have to wait till next time.
Okay. Save a little, keep it mysterious for a
Yes.
little while, right? Well, we'll keep watching this space, that's for sure. All right. Well, thanks for joining me for this podcast, Jeff. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember to visit our website at automationworld.com to stay on top of the latest industrial automation technology insights, trends, and news.